Everyone, please switch on your videos बच्चे जल्दी से because now we have to start the class. Yeah, Arhan. Okay. Okay. Everyone, please do this question. I'm giving you 2 minutes to solve this question. What is the force required to bring the object in to rest? Is this clear to all of you? This picture?
Yes, sir.
चलो ठीक. Answer me in the chat. These are NCERT examples. So how many of you solve the NCERT examples and questions after the class? Raise your hand in the chat. Okay, Hanan did. Only Hanan. What about rest of you? Acha, Arhan, Shike, Samia. But your NCERT is the key book. First of all, you have to attempt NCERT before any book. Okay? So you have to make sure that every time when you solve the questions, first do the NCERT questions, examples along with the exercise. Then you can move on to the any other book, maybe reference book together with or S-Chan book that I've given to all of you. So that is also an option, or you can find out the questions on the internet if you want extra questions. But NCERT should be the first priority, right, everyone?
Yes, sir.
Yeah, sure. Let me know the answer. Okay, I got the first answer. Let me check. Achha, Sarah gave me the answer. ठीक है, Sarah. Okay. Okay, Sarah Khan. Achha, Samia also gave me the answer. Chalo, that's good. It's very good that everyone is answering right now. Chalo, that's good. Everyone, one more thing. If your answer is basically coming in negative and positive, so please mention the proper sign because force is a vector quantity. So the possibility is that it can be positive, it can be negative, right? So you have to make sure the sign as well of the magnitude. Okay. ठीक है, सामिया अरहान, चिकनम, okay. Okay. Hanan, Arham, Saad, Sakudi Guru. ठीक है. No worries, Saad. You can give me the wrong answer as well. That's not an issue. At least answer whatever your answer is coming right now on the paper. Yeah, no need to worry about that. Okay, Arham, I will explain. Arham, you are not getting any answer, dear. चलो ठीक है, कोई बात नहीं. Okay. So first of all, let's analyze this graph. What the graph is saying to this, to the velocity. ठीक है, okay, Hanan. Okay. So velocity. So let's understand this graph. So velocity time graph is given. So the velocity time graph of a ball of mass 20 grams. So first of all, our responsibility, our job is to write down all the given values. Okay. Mass of the ball is 20 grams. Okay, so it is not an SI unit. So what I will do is that 20 into 10 to the power minus 3 kg. Clear? That's what I will do just for the simplification. Okay, 10 to the power minus 3 kg along a straight line in this on this table. Okay, now let's analyze the graph. So at time equals to 0, so this is the origin. So at time equals to 0, the initial velocity of the ball was 20 centimeter per second. Okay, it's 20 centimeter per second. So according to the graph, initial velocity was 20 centimeter per second. Am I right, everyone? And at the time equals to 10 second, the final velocity was 0 meter per second. And as you can see this thing, Bacho, this is a time interval. This is not a specific time or point, okay, instantaneous point. It's an interval of time, right? 0 to 10. So it took 0 to 10 interval of time to completely at rest, okay? So what will happen? What we do? So we have to find the time interval. So as you can see this thing at t equals to 10 seconds, the object is completely at rest. So it means that the object started from 0 second. So the time interval would be 10 minus 0 seconds. Yes or no, everyone? So 10 second is the time interval. Am I clear to all of you? Please let me know this.
Yes.
Yes, sir.
Okay. Okay,
Yes,
now
sir.
everyone. So we have to find the force that brings the ball to rest. First of all, I need acceleration. I have mass, but I need acceleration. So what I will do is that I have the first equation of motion, that is v equals to u plus at, to find the acceleration. Yes or no, everyone? Everyone, before
Yes.
putting the values or substituting the values into the equation, always mention the equation that you are using to the teacher. Okay, always mention, because teacher will say, like teacher will not look at what you have substituted. He will look, or she will look on the what you have written, right? So the formula should be the priority before writing or substituting the answer. So 0, v up is 0, u is 20 centimeter. अच्छा, before इसको मैं meters में convert कर लेता हूँ. क्लियर है? सेंटीमीटर 1 सेंटीमीटर कितना होता है? 100 मीटर, राइट? सो 10 टू द पावर माइनस 2 आ जाएगा यहाँ पे. सो ठीक है, सो ये आपका आ गया 20 इंटू 10 टू द पावर माइनस 2 प्लस ए वी नीड टू फाइंड टाइम इज 10 सेकेंड्स. चलो दैट्स ग्रेट. ठीक है, सो ए विल बी इक्वल्स टू नेगेटिव ऑफ 20 इंटू 10 minus 2 divided by 10 meter per second. So 0 will cancel this 0. So it is coming out to be negative acceleration of 2 into 10 to the power minus 2 meter per second. Obviously, if the object is decreasing the velocity, maybe or you can say that if the object has some initial velocity and after some time it became to rest, it means that there is a negative acceleration applied on the object or ball or any kind of thing, right? Negative acceleration. So that's why the acceleration is happening right now. Clear, everyone? Okay. So now I have got the acceleration. So according to the formula, that is force is equals to mass into acceleration. So I will substitute the values 20 into 10 to the power minus 3 into 2 into 10 to the power minus 2. This is in Newton because this is the SI unit, right? So 2 2s are 4. So it is coming out to be 40 into 10 to the power minus 5. So it is coming out to be 4 into 10 to the power minus 4 Newton. So if I basically write it down in the decimal, so it would be 0.0. As a negative sign is also there. I just forgot to mention it. Negative sign is also there. 0.04 Newton. Clear? So let me check who gave the right answer. So everyone, Arhan, no, not Arhan, it's Samya. Samya was the only one who gave the right answer. Very good, Samya. Okay, everyone, please do the please look at the screen. Okay, so I hope you got all the points that I've written on the screen where you have made mistake. Anam, Saad, Arhan, Sara, Hanan. Okay. Arham, is this clear, dear? Arham?
Yes, sir, it's clear.
Chalo, check. Chalo, check. Okay. So this is the question. Okay, please do this question, Jalil sir. This is also a very good question. Not that much good, but yeah. It's NCRT based. Please do this question. And after that, we'll start the third law of motion. That is the most, you can say, popular in the real world. तो बहुत बेसिक क्वेश्चन है, आप लोग जल्दी कर लो इसको. Any answer? अच्छा, I got my answer. Okay. मैम अभी आपके स्कूल में कौन सा चैप्टर चल रहा है बच्चे? ठीक है मैम. ओके. मैम, which chapter is currently going on in your school, dear?
Recently, we've started force and laws of motion.
ठीक है. It means that we are ahead of your school syllabus. So,
Yes,
like, no, your vacations are over, or like, the vacations are over now?
yes, sir, they are.
ठीक. Okay, Arham. Okay, Samia. Saad. Arhan. Arhan give the answer. No, Arhan. Arhan, what's your answer? Sarah. Rafe. Hello, Rafe. Assalamu alaikum.
Islam says, sir, I'm doing it. I joined late.
Okay, ठीक. Please do this question, Rafe. Rafe, why didn't you give the assessment in the last class, dear? The assessment was active, but you haven't submitted the assessment.
Oh, sir, sorry. I came to India, so
अच्छा,
little
चलो
chaos.
ठीक. No issues, sir. But from now onwards, please make sure of that. ठीक है?
Yes, sir.
Sure. Please do this question. Sure. Last 1 minute, everyone. I'm giving you last 1 minute to solve this, and then I'll solve it. Okay? Because we have to start a new topic, that is Newton laws of motion. Third law of motion. Okay, Sarah. ठीक है. Okay, Rafe. ठीक है. Anyone left? चलो ठीक, कोई बात. Let's do it. Question is saying a motor car is moving with a velocity of 108 kilometer per hour. So it's a very high speed, and it takes 4 seconds to stop after the brakes are applied. So obviously, if you are moving with a very high velocity, it will take a little bit time to stop, right? So calculate the force exerted by the brakes on the motor car if its mass along with the passenger is 1000 kg. So it means that the combined mass of both the car and the passengers are 1000. So first of all, write down the things. Take 1000 kg. And velocity, initial velocity was 108 kilometer per hour. Okay. So as you know this thing, Bacho, that mass is given in SI unit. So it's our job to convert it into SI unit, right? So it will be 108 into, what is the fraction?
5 upon 80.
5 upon 18 to convert it into meter per second, right? Okay, so I will write it as it is because I will basically cancel it after that. Okay. And with final velocity is 0, right? And time taken is 4 seconds. अच्छा इसको यहीं पे cancel करते देखते हैं. 3 और ये होगा 1 and 8 3 6 18. So ये आ गया 30 आ गया. 6 5 से 30 meter per second. ठीक है. So 30 meter per second is the initial velocity with which the motor car is running. Okay. So we have mass. I need the acceleration. So you can see this thing. Initial velocity, final velocity, and time is given. So the first equation of motion is completely of use. So V is 0, U is 30 plus 4A. Okay. So A is coming out to be minus 30 by 4. It means that minus 15 by 2 meter per second square. So why negative sign? Because the acceleration is nothing but retardation. It is decreasing the speed of, okay. So now simple, force is equals to mass into acceleration. That is mass is 1000 kgs into minus 15 by 2 Newton, right? So this is coming out to be, this will cancel this 500 time. So 15 5 is 75. Right. Clear everyone, this is the answer. Negative sign is that because the force applied is in the opposite direction of the motion. Please let me know everyone if it's clear to all of you.
Yes, sir.
Does anybody have any doubts so far?
No.
Sure. Okay. So that's these are the questions that will be there in your school exams. Okay. So I hope you got all the points. Okay. Does anybody have any doubts so far in this topic? Please let me know last time. Else we'll start a new topic.
No, sir.
Sure. Okay. Sure. So now it's time to start the third law of motion. Third law of motion. Okay, so basically, third law of motion is nothing but it's in simple words, it says that every action has an equal and opposite reaction. It means that suppose if I am pushing a wall, so wall is also pushing with the same force towards me. Clear? So that is a simple thing, right, everyone? And before that, let me give you an image like this. Right. So you can see this thing that in the play, you can see this thing that if a boy is basically pushing or basically applying a force on the wall, so the wall will also exert the same amount of force on the boy. Basically, we have so much real life examples, but that are a little bit offensive. So I just don't want to use them. Okay. But you got my point, what I'm trying to say. So everyone has seen this thing in the movies, in the real life as well. So that's what I'm saying. So every action has an equal and opposite reaction. Is if basically, if in the simple words, if I'm doing wrong, so same will happen to me at any point of time. I'm not saying that in the real world it will like occur instantly, but after some time. So it's a okay. So every action is an equal and opposite reactions. That's the simple line based on the third law of motion. Clear, everyone? Okay. So that is all in this, because this law is very simple. It's very like not that no numerical, only the conceptual points are there. Okay. So let me pick aside this picture. This is a law of the nature, because whenever we exert some amount of force, if I'm sitting right now, so I'm sitting, so I'm exerting force on the ground. So the ground is also exerting the reaction force of equal magnitude in the upward direction. Clear? If I'm basically pushing a pen in the down in the inwards direction, so the force applied by the pen is in the outward direction. So opposite the and the amount, or you can say the magnitude, would be same. Only the direction will be opposite to each other. Clear, everyone?
Yes, sir.
Sure, that's sure. It's good. Okay. So let me write it down. Just a moment. Pen got stuck. Is my pen moving right now? Is my cursor moving on the screen? Please let me know, everyone. Is my cursor moving on the screen? Is it visible to all of you?
Yes,
Sure.
yes.
Check. Okay. So in simple words, so it states that every body has an equal and opposite reaction. Okay. So action and reaction are the two forces that is involved. Okay. So if I draw this thing, देखो, so this type of diagram is called free body diagram. So right now this topic is like these kinds of forces are not there in the syllabus. Okay. Suppose that I'm applying a force in this direction. Okay. So the frictional force will be in the opposite direction like this. Clear, everyone?
Yes, sir.
Okay. Because frictional force works in the opposite direction. So this is frictional force. And the mass, or you can say the weight of the body, works basically acts in the downward direction due to the gravitation, or you can say due to gravity. And this force is called reaction force. Maybe not like two names are there for this force that is basically in the upward direction. It can be called as normal force or reaction force. Okay, so both the names are correct. Please let me know, everyone, if this is clear to you or not. So this of the
Yes,
body of
sir.
mass m, okay, having some acceleration a in this direction. So obviously acceleration is there. It means that force will acting, and the frictional force will be in the opposite direction. And this is the mass, that is the weight that is acting downwards due to the gravity. Okay, clear, everyone? So force would be equal to the negative of the you can say, अच्छा ठीक है, इसको इतना डीप में नहीं रखते because you will get confused. Just take it right there. ठीक है, so इतना ही रखते हैं इसको. Clear, everyone? Does anybody have any doubt? ये ground है आपका.
No,
ठीक है, so this is ground. So does anybody have any doubt so far? Please let me know once. ठीक है, so in this case this force is action. ठीक है, and for this force, if this is action, so this would be reaction, because this is applying basically in the opposite direction. Yes or no, everyone? So this is reaction. Okay, and if we talk about the mass or weight, basically, so for this is action. Okay, and this is reaction. Okay, so I'm writing it here. So n लिख देता हूँ या फिर r लिख देता हूँ. R would be better. So r हो गया. Please let me know, everyone, is this clear? ठीक है. Anyone get out so far? Please let me know once, Bacho.
What is a normal force?
Normal force or reaction force is the force in the upward direction when the mass is acting in the downwards direction. The force applied by the, you can say, ground, exerted by the ground. Okay? Yeah. Please let me know, everyone. Clear, everyone?
Yes, sir. Yes.
Sure.
Yes, sir.
Okay. So now let's understand some conceptual questions based on the Newton's law, third law of motion. Okay. So the first thing is that how do we walk? Okay, the first real life example is the you can say how do we walk, right? So basically we exert the force on the ground, so the ground also exert the same amount of force, right? So that's how we walk. Just a second, let me give you the picture of the man. How does it work? Okay, so first of all, so these are the conceptual questions that will be there in your school exams, that they will asking why there is a recoil in the gun after shooting, why, how do we walk, and why the boat moves in the backward direction when we basically step out from the boat, okay, in the forward direction. So these are the things that you will understand. Okay, so first is how do we walk. Clear? So basically, So let me write it down. Okay. So it's so we'll write down in points. 2 points would be enough to explain. Okay. So first point is एक diagram तो रह गया. Let me paste this diagram like this. So as you can see this thing, the first force, if the first basically with the back foot, you can see this foot. Okay. This foot basically making some action. So the force is basically the ground is giving the reaction to move forward. Okay. This is the forward movement is the reaction. The backward movement is the action. Clear, everyone? Okay.
Yes, sir.
Sure. So let me write it down. When walk on the ground. Pushes okay, everyone is in this diagram. Please remove that acceleration because for if this body is in equilibrium, so there will be no acceleration. Okay, because force and the reaction force are unequal in nature. Okay, please remove that acceleration word. So what pushes the ground backward and in return the ground pushes our foot forward. Pushes our foot forward. Okay. The forward reaction exerted by on our foot makes us walk forward. Clear, everyone? Please let me know. Any doubt so far to anybody?
No, sir.
Chicken. So that's how we move, basically walk forward. So now next point is why the gun recoils. Okay, why the gun recoils? So basically, obviously, so let me show the picture to you. Okay, how does it look like when a gun fire a bullet? So this is the thing that happens when a gun fires a bullet. So as you can see this thing, the gun fires the bullet in the forward direction. So when the bullet leaves the nozzle, or you can see you can say this pipe of the gun, it makes a kind of reaction in the backward direction that is called recoil of the gun. Okay, so that's what recoil is. Recoil is the backward movement of the gun when the bullet exits the you can say nozzle of the gun. Okay, clear everyone?
Yes, sir.
Yes,
Sure.
sir.
Check. So let me write it down. First point. Comma, force, sending the gun the bullet backward. Bullet forward is zero. Equal to the force. Act forcing okay. But due to high mass, it only a little distance. Distance and gives backward jerk or kick to the shoulder. On the of the gun. Okay. So whenever a bullet fires a bullet, okay, or basically a gun fires a bullet, so there is a backward force acting on the gun that basically jerk or kind of kick, basically gives a kind of backward jerk or kick to the shoulder, and due to that sometimes if it's not handled properly, the shoulder can be, you can say displaced, or it can be broken as well. Okay. So these are the points. So that's why it's very, like, whenever the training happens of the policemen and the soldiers. So so this is a part of the training as well, how to shoot a bullet properly without damaging the shoulder. Okay. So it's not an easy task to fire a bullet. So that's why everything requires a training, proper training, right, everyone? Okay. Sure. Okay. So now let's do uh, it's a boat, the case of boat in the ship. Okay. So that would be the last. So that would be enough. Okay. So what happens when you basically deboard from the boat? Okay. So when you go in the forward direction, okay, so the boat moves in the backward direction. Anyone of you have sit in the boat yet? Anyone?
Yes,
तो बैठा है बोट में या फिर कुछ इस टाइप का जो लेक्स वगैरह में चलती है?
ये सर मैं बैठा हूँ।
अच्छा, ठीक है। अनम, अरहम, सामिया, साद, नो वन। अच्छा, साद, ठीक है। I also I also had a ride on the boat. I think so in 2016. So I went to Kashmir for the holidays, like Srinagar. So that was my first experience for the ride of the boat. Okay, so, so yes. And please lower your hand here. चलिए, मैं एक पिक्चर पेस्ट कर देता हूँ ताकि आपको आइडिया हो जाए। ठीक है। So this is the case when you move forward from the boat, basically. So the boat will go in the backward direction due to the reaction force. backwards, away from. There, everyone. This is
Yes.
due. Backward direction. Okay. So the push of the man is action. Okay. And the board exerts the same amount of force, that is called reaction. Okay. Please let me know, everyone, is this clear to you or not? Does anybody have any doubts so far? Acha, one more thing, bacho, you have assessment. Okay, after this class, please, after 2 or 3 minutes after the class, you can check out for the assessment. Okay, so I'm giving the information
Okay.
for the same. Okay. So only last topic is left, that is the conservation of momentum, that we will do in the next class, and this chapter would be done. Okay. I hope this is clear to everyone. Please let me know.
Yes, sir.
Okay. So whenever there is a concept of action and reaction, nothing, third law of motion.